Hey everyone, I'm Mukesh from codewithmukesh.com, and in this video, we'll be covering the basics of setting up access to AWS services using .NET and the AWS SDK. So we'll be walking through various ways to secure the AWS credentials by using application settings, environment variables, AWS CLI Profiles, and IAM Roles. This will be the first video of the AWS on .NET series where I will be exploring most of the AWS services and show how the .NET developers can get started with them. This is an AWS sponsored video. The AWS credentials are used to authenticate into AWS services such as storage, computing, and databases. So in order to access these protected AWS services, the developers have to configure their .NET applications or environments with the required set of credentials. So these credentials are basically an access key and a secret key combination which I use to authorize and authenticate into AWS resources. Before getting started with the video, I assume that you already have an AWS account registered. If not, you can check out the AWS free tier, which is quite a generous tier that will help you experiment with the AWS services. For all my open source works, articles, and videos, I'll be using the same AWS free tier account. Once you have your AWS account ready, log into the AWS Management Console and in the search bar type in IAM and open it up. This should open up the IAM Dashboard that gives you an overview of the various IAM resources that are already available in your account, like the user groups, users, roles, and the related policies. Let's get started by creating a new user. On the side navigation menu, click on Users. So here you're going to see all the available users in your AWS account. Here, click on Add Users. Type in the required username, for example, YouTube Demo. You can also allow this newly created user to be able to log into AWS Management Console with a password. This is for you to decide. I generally use my root email and password for logging into the AWS Management Console, which is secured by multi-factor authentication on my mobile device. And when I decide to use .NET applications, I use the newly created user's credentials. This way, even if there is a scenario where my access keys are leaked, the root account is always secured and can be used to remove the leaked user as well as rotate the credentials. For now, I'm not enabling the console access for this user. Click on Next. This is where we'll have to define the permissions available for this newly created user. You can do one of the following. Add the new user to an existing user group or create a new user group as well. So what are user groups? User groups helps when there are a large number of users who would like to share the same kind of AWS permissions. For example, if a group has only S3 access defined, any user that is being added to this group will inherit those permissions. The next option is to copy permissions from an existing user. And finally, you can also attach the policies directly. Here, you can define permissions for each user directly. This might be easy at first, but if you have an ever-growing user base, this might be tough to maintain to manage access. Thus, the best approach for now would be to create a user group, attach policies to the user group, and add this newly created user to it. So select Add Users to the user group and click on Create User Group. Type in a user group name, something like YouTube Demo Group. For now, scroll to the bottom and create an user group. So once the user group is created, you will have to select the user group, for example, YouTube Demo Group, and click on Next. In this screen, you can review your modifications, add a couple of tags if needed, and click on Create User. And your user is successfully created. Now, let's add a couple of policies to this user group. Click on the newly created user, that is the YouTube Demo, and navigate to the Groups tab. So here you can see the newly created group as well. Open up the demo group and click on the Permissions tab. As you see, there are 0 permissions attached to this group. We'll add a couple of permissions here. So one great thing about AWS permissions is that it's very granular and very well segregated. This helps in clearly setting permission boundaries for users and securing everything else around it. So click on Add Permissions. And let's create an inline policy. So for this example, let's say we currently need our users to have access only to list out all the S3 buckets. Thus, let's select S3 service. So as I mentioned before, the user should be having access only to list out all the buckets. So let's click on List. So all the permissions under List will be selected. Adding to this, we can also specify which resources should be involved in this permission. For now, we'll be selecting all the resources. That's it. Let's click on Review Policy. Here, let's give a new name. I named it List S3. Let's create a policy. You can see that the new policy is being attached to this particular demo user. So this means that all the users which are under the demo user group will have the S3 list policies available. Now that our user has the required permissions, let's see how to extract the AWS credentials for this user. Open up the Users tab and select the new user. Here, click on the Security Credentials tab. Here, you'll be seeing a couple of access-related options for your user. Our main goal is to generate AWS keys for this user. Let's create a new access key. In the next screen, based on the purpose of why you need the access key, AWS suggests a few alternatives other than generating access keys. But for now, let's click on Others and continue. Let's give this a dummy description and create the access key. In the next screen, you'll be presented with a key and a secret. Ensure that you download the CSV file for later use and store it securely. Note that you'll not be able to see the secret key once you move away from this page. Thus, make it important that it's secured. So now that we have the credentials and we are aware that these set of credentials have complete access to list the buckets of S3, let's create a .NET Web API that will have an endpoint to connect to the secured AWS S3 API and retrieve a list of buckets. Let's open up Visual Studio and create a new ASP.NET Core Web API project. I'm naming my solution as Cred Demo. So this will be a .NET 6 project. Once the solution is loaded in Visual Studio, let's first install the required packages for accessing S3 service via client. Let's install the following packages using the Package Manager console of Visual Studio. You can find the name of the packages in my blog post, which I have linked in the description of this video. So once that is installed, add the following lines of code to your program.cs. So this will be responsible for loading configurations from Appsettings that we'll be adding next, and also initializing the internal AWS S3 client. Now open up appsettings.json and add the following. We will add a couple of more properties later in this section. For now, we have only defined the AWS region, which in my case is AP South 1. Also, make sure that you have at least a couple of S3 buckets already created for this demo so that we'll be able to list it out. I have already written a detailed article about working with AWS S3 and integrating it with .NET applications. You can find a link of this article down in the description of this video too. Now that our solution is set up, let's add a new API controller to our project and name it Buckets Controller. So once you have created the API controller, let's add a new endpoint. I have already kept an endpoint ready for you guys that is going to list out all the S3 buckets available. So as you can see here, we have added a new endpoint to our bucket controller named list. This would essentially print out a list of available buckets from our S3. Note that I have also added the access key and the secret key here that we have downloaded earlier from our CSV file. Here, we are creating a new instance of an S3 client using our previously generated access and secret keys. Make sure that you add your credentials here. Next, we are using this client to call the list buckets API, the result of which we'll be printing in the next line. As simple as that. Let's run the application and navigate to API/bucket/the list. As you can see, we are getting the response as required. But this is not actually how you would be maintaining the AWS credentials in your code. You would have already figured it out. The main issue is that we are hard coding our access keys within the source code. This is not a recommended practice. Use this approach only if you intend to run the code for demo purposes. Never push these changes to your remote repositories, as this may prove fatal once it is on the wrong hands. Also, once you're done with your demo, make sure that you deactivate your access keys or even delete them. Next, let's talk about adding credentials to Appsettings. So apart from the hard-coded approach, you can also add the credentials to Appsettings.json and read the values at runtime into your code. The code for this would somewhat look like this, where we are injecting the I configuration, which is actually going to read from the Appsettings.json using the AWS access keys and the secret key. So for this to work, you'll have to ensure that the access key and secret key is added to your app settings like this. Another issue is that you should be careful enough to not check in the Appsettings.json into your repository. In local development environment, for a more secure way of storing AWS credentials, or rather any secrets, you can also make use of Secret Manager that comes built in with .NET. So right click on your project and click on Manage User Secrets. This will create a new secrets.json for you, which will be stored securely at your user profile location locally. So to this secrets.json, you can add in whatever sensitive information you want to secure. For example, in our case, we would like to add the secret key and the access key. So what I would do is copy over the entire set of data, add it here, and remove what is not required. So we have actually secured AWS access keys and secret key. Now you're free to remove the AWS access keys and secret key from appsettings.json, and it would look like this. So what would happen is whenever the application is running on your machine, it would fetch the data from secrets.json, which is more secure, and there is no way that this will be checked into the repository. So all of these above approaches are suitable for local development purposes only. Let's say you dockerize this application and spin up the Docker container. In such cases, using environment variables to set up the AWS credentials can also be a good choice during development. So the following example shows you how you can configure environment variable for a default user. Apart from this, AWS also has its own credential store that is stored locally on your machine. Let's get started by installing the AWS CLI tool. You can follow the steps to install AWS CLI on your machine. Note that I'll be providing all the links in the description of this video. So by default, these credentials are stored in your user profile folder if you're using Windows under the .aws folder in a file named credentials. This is what my credentials file look like. I have a predefined profile that has complete AWS admin access. Note that this profile is named as default, and I have redacted the access and the secret keys for security reasons. So once you have installed the AWS CLI, open up a command line terminal and enter in the following to verify your installation. So once you have verified that the AWS CLI is properly installed on your machine, let's create a AWS profile locally that will hold our access keys and secret keys that we generated in a previous step. On the same terminal, run the following command and enter in your access keys and locations. You'll be asked to enter the secret key, access key, and the default region name, post which you can navigate to the same credentials file to see your newly added demo profile. So here is your newly added YouTube demo profile. Now that we have added the new profile, where exactly can we use this? To understand this, let's navigate back to Visual Studio, where we have written a piece of code to access the S3 bucket list. So firstly, I would remove the credentials stored in secrets.json because you no longer read this. As of now, the application is supposed to read the credentials directly from the AWS CLI Profiles. The AWS SDK is smart enough to find the credentials based on the profile name from the credentials file stored in your user profile folder. So for this, let's make some additional changes in our controller. Now we no longer need the iConfiguration service. Instead, we'll use the iAmazon S3 service. Apart from this, we also no need to read from the configuration files. And since that we have already injected the iAmazon service within the containers DI, we will no longer need to create a new client as well. So instead, we can directly use the Amazon S3 service. So here, we injected the iAmazon S3 client instance into the constructor of the controller. Remember, we added a certain service registration to the program at the beginning of this article. So that is somewhere over here. Yeah, this one. It will internally load the profile data, which we are about to add in the app settings, which will be resolved by AWS SDK by pulling the secret key from the local credential store. So open up app settings and add in the profile data. With all these changes, once you run your application, you can see that the response comes back as expected. Let's build our application and run it. So this was the tab that I had opened earlier to check the response of the API endpoint. Let me refresh it. You can see that the response remains same. This is how easily you can integrate the AWS CLI profiles for authenticating into AWS services. Till now, we have discussed about applications that would run outside the AWS world. But what about the applications that are going to be hosted within the AWS infrastructure? For instance, let's say we have a simple AWS Lambda, which would just be responsible for returning a list of S3 buckets for demo purposes. How will this Lambda get permissions to access the S3 resources? To demonstrate this, let's create a new AWS Lambda project, add some basic S3 SDK calls like we did earlier in the web API, and push the Lambda to AWS and see what happens. Note that in the upcoming videos of the series, we'll be going in depth about all of the services that I have mentioned, like AWS S3, Lambda, gateways, and so much more. I thought it would be critical to keep this video as the first video of the series, since it deals with setting up the credentials for your development environment. The next step would be to open up Visual Studio again and create a new AWS Lambda C# project. If you do not already have the AWS Toolkit extension installed on your Visual Studio, please get it installed. You can open up Visual Studio, navigate to the Extensions menu, and manage extensions and search for AWS Toolkit. Make sure you have this extension installed on your instance. So once you're done with the installation, let's create a new AWS Lambda project. So this is the project that I'm talking about. It's an AWS Lambda project with .NET Core support. Let's create a new one. Let's name it Lambda Demo. Once that's done, create a Lambda project and choose an empty function blueprint. Note that we'll be exploring most of the other templates in the upcoming videos. Click on Finish. Now navigate to Function and replace the function handler method with the following code. So let's resolve all these dependencies. The first one would need to install AWS S3 package. Again, what we're trying to do here is the same exact thing that we did earlier with the web API. We are just going to get a list of S3 buckets from AWS against the provided credentials. But in our case, it is not going to be the credentials, rather it is going to be the profile. Now, another interesting aspect of this is that AWS Lambda project has a AWS Lambda tools default JSON, which is more or less same like the appsettings.json that we have in our API project. With all these changes in place, let's run the Lambda mock tool. Now to test our code, let's run the Lambda mock tool. So to do this, you will have to install the Lambda mock tool globally in your system. You can do this by running the following .NET command. It goes by .NET tool install global amazon.lambda.testtool and the version we are going to use, that is 6.0. So once that is installed, you will just have to go back to your Visual Studio and run the mock lambda test tool. So once the test tool loads up, you can select the default profile that is needed, which is going to be default. And you can also see the YouTube profile that we have added earlier. So the problem with this is that it just has the S3 access. So for all my demonstration, I'll be using the default credential profile. To give an idea of what my administrator has as permissions, let me open up my account. So here you can see that this particular user has the complete administrator access. This is usually good when you're completely doing all the development stuff locally in your machine. Let's go back to the .NET mock tool. So here you can see the function name as well as the region. You can change all these data and send in an example request. So for example, let me execute the function. If things went well, you'll be able to see a list of S3 bucket names in the response section of this test tool, that is here. Now that our Lambda is functioning as expected locally, let's push the Lambda to AWS. With Visual Studio, it's as simple as right-clicking the AWS Lambda project and clicking on Publish to AWS Lambda option. So here you can see the Publish to AWS Lambda. Here, we'll just have to select the default profile and give it a function name. Let me give it as demo. So this will be the function name. This will be the name of the Lambda function that you will see on your AWS console. Click on Next. In the next screen, select the AWS Lambda execute role. Note that this role comes with basic permissions like get, put, S3 operations, as well as complete access to write application logs to CloudWatch. Importantly, note that this role does not have the access that we are looking for, that is the S3 list permissions. So ideally, when we upload this particular Lambda to AWS and try to execute it in the cloud infrastructure, it should return with a 401 not authorized exception. With that done, let's click on upload. So this would create a default role for your AWS Lambda and upload the package to AWS Lambda. Once done, let's open up the management console and navigate to AWS Lambda. Now let me switch to AWS Lambda. So from here, you can open up Lambda or search for Lambda in the search bar. Here, you can see that our .NET 6 package is uploaded as expected just 36 seconds ago. Click here to open it. Now, once the Lambda is loaded, navigate to the Test tab and click on the Test button. So, as I mentioned earlier, once we try to test the Lambda, it should return with an exception since it does not have the basic permissions to access S3 list. There you see, our Lambda does not have permissions to access the list bucket endpoint of S3. So how do we fix it? This is pretty straightforward for AWS resources, especially in the case of Lambda since it already lives within the AWS world. So for this, go into the Configurations tab and click on Permissions. So here you can see the role name that is associated with this Lambda. From here, you might have already guessed how to handle it. As we did earlier, we should be adding some inline policies to this Lambda so that it has enough permissions to access the required endpoints as well as the AWS services. Let's open up the role. So to this permission policies, let's add a new permission and create inline permissions. So here, as we did earlier, select S3 and select all the list access levels, and in the resource section, make sure that you have selected all resources. Review policy and name it something like Lambda test and create a policy here. So now you can see that this particular role has complete access to list all the endpoints of S3. Let's go back to our Lambda. Let's open up the test tab again and click on test. Now we can see that the result is succeeded. Here you can see the response as expected, so which is going to be the list of S3 buckets. So this is how you can secure AWS credentials within the application as well as while doing local development. So when applications are hosted in the AWS infrastructure, it's always best to attach roles to these resources. You can always add the AWS secret keys into the environment variables of these lambdas as well. So you can do this by going into configurations and setting the environment variables here. But instead, we have a much better options where you can set the permissions directly for the user role. This is why relying on AWS secret is not always ideal approach, at least when you're inside the AWS world. IAM permissions and the roles can be very effective when the hosted application stays within the AWS world. Another tip is that in case you are to use the AWS credential keys, ensure that you do a key rotation at least once every few days depending on the sensitivity of the resource that you're trying to protect. In the upcoming videos of this series, we'll be going through other AWS services like S3, Lambda, gateways, and so much more, and how it can be integrated with .NET applications. If you're new to this channel, kindly support by subscribing and liking this video. Also do share your valuable feedback in the comment section. For a written version of this video, please visit my blog post where you can find all the required links and codes. I would also want to give an update about the .NET Microservices boilerplate that I'm currently working on. So it's going to be under the FullStackHero handle in GitHub, and the idea is that this is going to be a boilerplate that will allow you to bootstrap a complete microservice architecture .NET solution in no time with all the features you would need. So for now, I have added all the basic integrations like Swagger, Serilog, Fluent Validations, Mediator, Automapper, and so much more. I have also added the support for API testing, which will be using a tool or a Visual Code extension called as Thunder Client. Apart from that, we have added all the other basic functionalities like reverse proxy using YARP API Gateway, IDD Server 6, which is going to be a separate microservice for serving and validating JWTs based on the scope and the grant type as password. Also, the Dapper integration for microservice communication. Entity Framework Core with Postgre integration, MongoDB integration for a specific catalog API service, and I have also added a couple of GitHub workflows which will help in building the projects within the pipeline. As well as I have added the exception handling middleware semantic release, about which I'll be having a separate video, and also there's a tie support. Adding to this, I have also written down some steps if you want to run the solution locally in your Docker desktop. Also, there is tie integration which you can read through. Do support this project by leaving a star to this repository. Thank you guys, and see you in the next video shortly.